Hello, and welcome back to Error Analysis Essentials, a series brought to you by Physical Sciences Consultorium, where we explore key concepts in error analysis to help you refine your scientific measurements and calculations. So far in this series, we've discussed the fundamentals of error analysis, the differences between systematic and random errors, measurement uncertainty, and most recently, the importance of significant figures in maintaining precision. Today, we're going to build on that foundation and dive into a crucial topic, error propagation. This concept is key to understanding how uncertainties in measurements can affect your final results. First, let's define what we mean by error propagation. In scientific terms, error propagation refers to how uncertainties in individual measurements influence the uncertainty in a calculated result. Every time you take a measurement, there's some degree of uncertainty, and when you use that measurement in further calculations, the uncertainty can propagate, meaning it can affect the accuracy of your final result. For example, imagine you're measuring the length and width of a rectangle to calculate its area. If there's a small error in either the length or the width, that error will propagate into your calculation of the area, making the final value less certain. Understanding how to manage this propagation of error is crucial for ensuring that your results are as accurate as possible. When you add or subtract quantities, the uncertainties associated with each measurement contribute to the uncertainty of the result. The rule here is to add the uncertainties in quadrature, meaning you take the square root of the sum of the squares of the individual uncertainties. When you multiply or divide quantities, the relative uncertainties, which are the uncertainties divided by the measured values, add up. This means the final uncertainty is the sum of the percentage uncertainties of the quantities involved. When raising a measurement to a power, or taking its root, the relative uncertainty is multiplied by the power. So why is understanding error propagation so important? In the real world, whether you're working in physics, chemistry, engineering, or any other scientific field, being able to accurately assess and manage uncertainty is crucial. For instance, in environmental science, when calculating the concentration of a pollutant, the uncertainties in your measurements of volume and mass can significantly impact the reliability of your results. Similarly, in engineering, the propagated error in material properties could affect the safety and stability of structures. By correctly applying the rules of error propagation, you can ensure that your results are both accurate and reliable, which is essential for making informed decisions. Of course, as with any calculation, there are common pitfalls to be aware of when dealing with error propagation. It's important not to ignore uncertainties at any stage of your calculations. Always carry through the uncertainties from each step to the final result. Avoid rounding numbers too early in the process. Rounding should be done only at the final step to ensure that the propagated error is as accurate as possible. Be mindful of the difference between absolute and relative uncertainties, and combine them appropriately based on the type of operation you're performing. By keeping these tips in mind, you can avoid some of the most common mistakes and ensure that your error propagation calculations are accurate. In summary, error propagation is a powerful tool that helps us understand and manage the uncertainty in our results. By applying the rules we've discussed today, you can ensure that your scientific calculations are precise and reliable. If you found this episode helpful, please like the video, share it with your peers, and subscribe to our channel for more insights from Error Analysis Essentials. We also encourage you to leave your questions and comments below. We'd love to continue the conversation with you. Thank you for watching this episode of Error Analysis Essentials. In our next episode, we'll explore the concept of confidence intervals and how they provide a range within which the true value of a measurement is likely to lie. Stay tuned for more. Until next time, keep questioning and keep learning.